Hey YouTube, welcome back. First of all, congratulations for watching all of that. It's our last episode of the system design fundamentals. Or maybe we could add another series talking about some concepts like proxies and hashing, things like that. But I guess for this one, this will be our last system design fundamentals, this last video on system design fundamentals, and after that we could start into designing and actual systems. And basically, if you are new here, basically I'll just suggest that you should watch all of the previous videos. However, if if you watch the videos before and you don't remember what we had, I'll just make a quick walkthrough and talk about the main concept with each database scaling, like sharding specifically. So basically, let's just go in. I'll just make a small quick overview about this system so we will understand what we are building. We have the client. The client accesses the load balancer IP address from a domain name system service. Basically, it's provided by third parties. Basically, the client sends the domain name and the DNS sends back the IP address. Once the client receives the IP address, the client will connect with the load balancer with the IP address and with the HTTP protocol. The load balancer will take the requests that are coming from the clients and just distribute them across multiple web servers and across multiple regions. Basically, the client we are using a GeoDNS, so we make sure that when we had a client is like in Europe, you will access the servers in Europe, and for each region we have multiple. We have WebT. Each WebT we have multiple web server basically, and the load balancer manage distribute the requests to these web servers. And if one of the web servers went down, the other web servers will continue working, and the load balancer will redirect the requests that are going to this web server to the others web servers. And we had the data tier. That is, we had a master-slave relationship. Basically, the master will serve the write operations. The slaves will serve the read operations. If one of the slaves went down, the other slave will take the request. If one of the master went down, one of the slaves will get promoted to be the new master. And also we had and right now our application is available, is scalable to improve. And right now we want to improve the speed and decrease the latency basically, and improve the user experience. So basically, we create a cache in memory, and the cache, it's in memory storage. Basically, we store in it the frequently accessed data. For example, that we have this web tier. So basically, instead of the web server just directly asks the data tier, it just asks the cache first. If the cache has the actual data, it get it directly. Otherwise, it will get it from the database, and after that stored again in the cache. And we should make sure that when we have the cache, we don't put the expire policy too long or too low. If it was too long, the data couldn't be consistent, or we could read unpresent data. And if it's too short, maybe each time we access the cache will be empty. And we have other thing that called a CDN, content delivery network. It's basically it's used to store the static content into the closest geographic position to the actual client. So basically, if the client try to access a specific image, and this image basically lives in a server like 100 kilometers away, and the CDN will cache this image and will just store it in a close server. So basically, maybe like a 10 kilo, and this is improve the latency and improve the user experience. And also we had here we are stateless. We have a stateless WebT. Basically, the web server doesn't store any state, and instead of because if each web server stored state, for example, that each web server store, for example, user token, or maybe like it's user session, things like that. If this web server went down, the user will not, if the user connected to one of the second two server, it will not be able to use it as used the first one, because their data is not in these two servers. So basically, and even if the request just was routed to different one, to be the same result. So basically, we created a shared database, and we used NoSQL database to make sure that, because it's easy to scale, basically it's easy to scale out, and we use the NoSQL database basically for this specific reason. We share right now the all of the sessions and like the tokens, things like that, we share in NoSQL database, so the web server can any web server can access them directly. And also we had for the workers, maybe we had one of the users want to update image, update video, things like that. So basically we had workers should be do this asynchronously. And if we want to do that, we could have two ways. Maybe like the web tier would just ask the workers and would just wait for like for an amount of time, or maybe like just to try to ask the workers like each moment like 5-6 minutes to make sure if it's done or not. And this is not that scalable at all. So basically we created a message queue server, a message queue basically that when web tier wants to request a new job to the workers, basically it push it to the message queue. The message queue send it to the workers. Once the worker finishes the request, it will send it back to the message queue, and the message queue will send it to the web tier, and the web tier will send it back to the client directly. And right now our application was getting quite big, and we have a global audience. So basically we created a centralized data basically, and served for each region. And the load balancer is responsible to distribute the incoming request to a specific region with a specific user, and using a DNS geo DNS service to make sure that when the user in Germany see the thing is only in Germany. And we also had the last thing that we have a big application, so we need to know what's going on. So we're using logging, monitoring, automation, and metrics. And yeah, that's it. And I guess everything looks fine. However, we have that last thing that was with our database. Maybe our database, we have tons of data right now, and right now we have these three databases, but each one of these databases, each one of them can't have all of the amount of data by its own. Oh, sorry. So let's just copy this one. Okay, so basically each one of these databases can handle all of the amount of data, because right now we have only one database. Yeah, we have three, but we only have 3 servers, and each one of them store all of the data inside them. So basically, in order to make sure that we are let's say that we are getting more data, or maybe like the master is copying tons of data to the slave, and or the master getting tons of data. So basically we have 2 options. We can use something called the vertical scaling, and we can and basically we can just add CPU, RAM, disk, and it's the same as a web server. And I guess this will be fine for small projects, but right now we are a global project, so we can't use vertical scaling because it's quite a risk, and it has a quite limit. So basically we can use what it's called our horizontal scaling. So basically in this horizontal scaling, in this database, just make it just bigger, okay, and delete this one, and give me something. Oh no. Basically in this we will break this database basically and into shards. Wait a minute. So what we are going to do here is that we will take this one database and just break it into shards. And let me just Okay, so basically, we break this we will break this and we break this database basically into shards. Basically, what we are doing right now called horizontal scaling. It's also known as scaling out. It's basically involves basically we adding more servers or nodes to the distribute work across multiple machines. Basically, we add more servers across these machines. And basically, in horizontal scaling, the architecture data is basically it's we save it across multiple things, and we maybe save them by user ID, something like that. Basically, we use something called database sharding. Database sharding basically involves like partitioning the database into smaller, more manageable parts. So basically, instead of have one big part, we just put them into smaller, manageable parts, and we called shards. So each one of them called shard basically, and each shard can be stored a separated server or set of servers basically, and basically it can manage independently and it's easy to manage basically. Basically, this improves the performance, the scalability, and also reducing the amount of the data that needs to be scanned for each query. And for this one, basically, what we are doing right now, because we have shards, and we basically when we have the shards, it's just that we have the data, and we just put this data into small shards, and basically when we have the shards, maybe we store the shards based on user ID or something. Because right now, let's say that I am a user, okay, and user, and sorry, there is a helicopter. I don't know if my voice is right working or not. Okay, the helicopter is done. It's gone. Okay, so let's say that I'm an actual user, and in the shards we take the data, and we just instead of store the data in just one big component, we put it into small shards. So one of the things that we can handle the shard, for example, like we could use a hash function. For example, maybe we can use a hash function that built based on the user ID or something like that, or user email, and based on this hash function, we will store our data into specific shard. So basically, when we want this data, we will go directly to this shard. So yeah, for example, like that. So basically, we store all of our data in this shard based on our ID. So this is what we're calling the key basically. For sharding, we had something called the sharding key that allows us to basically to retrieve and modify data effectively by route key basically, and this make way more easier because we don't have to when we have when we want to request the user, we don't have to go to each basically shard and search. No, we know the shard directly, so we go to the shard directly. Basically, the sharding data is needed basically when a single shard, because in this one, each one of them is represent one shard, and one shard it's not enough. So basically, we should break this one shard to multiple master shard and multiple slaves shards, each one of them. So basically, the sharding data it's need basically when a single shard is not it can't handle the amount of data. And also, if maybe if a specific shard gets tons of requests, so it can't handle all of that. And maybe you have two problems, maybe more with with how to joins, how to use joins basically. So basically, when we shard the database across like multiple servers, it can be hard basically to perform a join operation. And a common solution for this problem is to use something called a denumeralized database. So that basically the queries can be performed in a single table for for this basically when we shard the database, basically like to support rapidly increasing the data traffic, basically, because this is one of the most things that it's quite hard, basically. This is why we use sharding. And maybe that's it, basically. And I hope my description was quite good. And yeah, that's it for today's video. And hope that my discussion was the helicopter again. So that's it for today's video, and hope my description was quite good, and we finally reached the end of this series. And thank you basically for listening that much. And if you like my content, make sure to subscribe and hit the notification bell so you will never miss a video. And yeah, that's it. See you in future videos.